find the amplitude, period, phase shift, and graph one complete period. When we're graphing, we're still going to span the entire graph like we did yesterday. So span the entire graph given. Then use a highlighter, or really any color pen is fine. Then use a highlighter to box in one complete period. Okay, so I want you to span the entire graph so that you can see what's happening as you continue to go to follow your pattern. But then you're going to box in one complete period, which is where that formula is going to come in that we talked about earlier, where you start with your phase shift and then you go to the period plus the phase shift. Okay, so we'll do that part together. Okay, so for part A, we have y equals 3 times the cosine of x plus pi over 4. And then if you guys want to work ahead, I'll give you the b and the c. So y equals 1 plus the cosine of 3x plus pi over 2. And then c is y equals the sine of 3x plus pi. Okay, so if you want to go ahead, you can feel free to do that. If you want to stay with me, that's fine too. Just make sure if you go ahead, you check back in and make sure that you have the same answers that I do. All right, so the first thing we're going to do is find the amplitude. Like we said on the front page, the amplitude is still going to be the same as yesterday. So how would you describe to somebody where the amplitude is? Yes, in front of the function. Okay, so for A, what's our function? What's our function? Cosine. Okay, so the function is cosine. The number in front of cosine is 3, so our amplitude is 3. I want you to find the amplitude for the other two graphs as well. And I'm passing you out this for your homework. On your homework, you'll have 10 graphs again, so the last two, or maybe there's just one extra. You can either just put it on the back and use that same scale, or on your 5-3 day 1, you should have 4 extra graphs. You can put it on one of those. For what? For your homework. Okay, so then your amplitude, we already said for this one, it's going to be 3. This is your A value. Okay, and then Kaden, for the amplitude for B, what did you get? Yep, and that's because your cosine in front of that, there's no number. That's why it's 1. It has nothing to do with this one here. Even if this was 2, the amplitude would be 1. Okay, and then Aiden, what about the amplitude for C?
I also have 2.
Yep, so there, in front of the sign, there's just going to be 1. Yeah, Nick?
Can I just double up on the graphs?
No. Okay, so then your period is 2 pi over k. Okay, so I want you to go ahead and find your period for A, B, and C. Okay, so remember we talked about yesterday, where do you find k? In front of x. Okay, so what number's in front of x here? 1. So then your period is just going to be 2 pi. No, it's not. Never be that. All right, so then our k value for B is what? 3. Okay, so in front of the x is 3, so your period is going to be 2 pi over 3. What about for C? Same thing, 2 pi over 3. Okay, and then we'll do the phase shifts with each one as we get there. Right, so my phase shift, first, if I'm going to find it, I have to make sure that my coefficient is 1. Is my coefficient 1 here? Yep. Okay, so then your B value, because this is positive, is negative pi over 4, which means you're going pi over 4 units to the left. All right, now remember, earlier we talked about how 1 period is equivalent to B and then B plus the period. So that's what we're going to do here. So 1 period is going to start at negative pi over 4, and it's going to go to negative pi over 4 plus the period in this case is 2 pi. Okay, and if you're going to add these two together, you can get a common denominator. So the common denominator would be 4. So 2 times 4 is 8. So isn't 8 pi over 4 still 2 pi? So if I add those together, what do I get? 7 pi over 4. Okay, so that's going to be 1 complete period. And I'm just going to show you a rough sketch real quick about what that means. Okay, so normally when you have the cosine, you're from 0 to 2 pi. You have your max here, and you have your max here. Directly in between, you have your min, and then halfway. Okay, now if you're shifting this graph over negative pi over 4, if this is negative pi over 4, you have to shift this over negative pi over 4, which is really just a quarter, right? So you're subtracting the quarter. So now your graph would start here and end here. Halfway in between, you'd still hit your lowest point. I'm just going to show you this with a dashed line. Okay, so that's what's happening, is you're just taking this solid graph and you're moving it over to where the dash graph is going to be. Okay, so you're just shifting that over. So because our phase shift is negative pi over 4, what should be our units on our graph? Pi over 4. And I'm just going to write that out for the first one so you know where that's coming from. So since you are shifting pi over 4 units left, pi over 4 would be the best choice for the intervals on your x-axis. Right, so when you're doing pi over 4, what we're going to do is we're just going to be counting. And when you're counting, you can do every other one. So remember from yesterday, here were our labeling rules. So you were going to label the x-axis below, at the very least, label every other one. When you're labeling the y-axis, label your min and your max value on the y. And then I only want the y-intercept if you don't have a phase shift. So today we're doing phase shifts, so you won't have to label what your y-intercept is. And that's because when you're shifting it over, it's not necessarily going to be a nice point. Okay, whereas yesterday we did have nice points for our y-axis. Okay, so if it's pi over 4, I'm going to start here. This is 1 pi over 4. which means my next one is 2 pi over 4, which reduces to pi over 2, 3 pi over 4, 4 pi over 4, which is pi, 5 pi over 4, 6 pi over 4. 6 over 4 reduces to 3 over 2, so that's really 3 pi over 2. Then I have 7 pi over 4, and then 8 pi over 4, which is 2 pi. And here I have negative pi over 4, negative pi over 2, negative 3 pi over 4. Okay, so really, like I said, you can just label every other one. I just wanted to show you how we're counting to get all of those intervals. Okay, and then in a similar fashion to yesterday, you can figure out what your highest point's going to be. So if the cosine maximum is usually 1, now it's going to be what? 3, because it's multiplied by 3. Okay, so we know that 3 is going to be our highest value, so 1, 2, 3, I'm going to label that. And then 1, 2, negative 3, that'll be our lowest value, so I'm going to label that. Now, yesterday when we were starting our graphs and I did the table, where did I always start? At 0. Now, I'm going to start somewhere different. Do you guys know where I want to start for this one? Yeah, so whatever your b value is, that's where you're going to start. So negative pi over 4. Now, when I plug in negative pi over 4, what happens? What's negative pi over 4 plus pi over 4? 0. Okay, that's why I'm plugging it in. The cosine at 0 is what? 1. 1 times 3 is 3. Okay, so then my point is at negative pi over 4, 3. And then I'm going to use the pattern to do the rest of it. Okay, so the pattern tells me that at the end of my period, I'm going to be at the same place. Here's the end of my period. So this is one complete period. So if I'm starting at negative pi over 4, the end of my period is 7 pi over 4. And I know I'm going to hit the same value. Now remember, this is all coming from your original cosine graph, where it starts at the max, it ends at the max. Halfway in between the two maximums, what do you hit? The minimum. See how this is halfway in between? It'll hit the min. So how many units do I have from my starting maximum to the ending maximum? 8. So halfway in between is going to be where? Okay, so if I go 1, 2, 3, 4, I'm at 3 pi over 4. Now you can do this two ways. You can either rationalize it or you can plug it in. Once you know it's 3 pi over 4, if you do 3 pi over 4 plus pi over 4, what do you get? 4 pi over 4, which is pi. The cosine at pi is negative 1. Negative 1 times 3 is negative 3. Okay, and so here's my negative 3 pi over 4. Now, halfway in between those, it was hitting the x-axis. It's not always going to hit the x-axis, but it is always going to hit halfway in between. So if you take your max value plus your minimum value and divide it by 2, that's how you'll get these 2 points. So if my max value is 3 and my minimum value is negative 3, 3 plus negative 3 is 0. 0 divided by 2 is 0. So this one, halfway in between, it's going to hit 0. Okay, and then I can go ahead and connect these with a curve. So see how I just kind of curve each one up? So I just do it one little leg at a time. Okay, and then if I go 2 more units, I'm going to be hitting this value. And then if I go 2 more, I'm going to be hitting this value. Okay, and then you're going to take your highlighter or your pen, and you're going to box in one complete period, which we already found. This is your one complete period. Your one complete period is going to be from negative pi over 4 to 7 pi over 4. And then can you see how that looks just like our standard cosine graph?
I have a question.
Yep.
Are we gonna be asking our homework to box in the period, or are
To-
you just doing that for learning purposes?
For, wait, say it again, to box in a period? No, I want you, is that what you asked?
Yeah, are you
I-
doing it for learning purposes, or are we gonna do it for homework?
I want you to do it for homework because you're going to have to do it on your quiz.
Okay.
Yeah. Okay, so yeah, on your quiz it'll look just like this, and I'll tell you to box them in. So I do want you to practice that. Or a pen. Okay, so for this one we have to find our phase shift. So the phase shift is going to depend on what your K value is. So see how in front of the X we don't have a 1? So then what do we have to do? Factor it out. So when you factor this out, it's just like you're multiplying by what? Yep. So if you factor out the 3, you multiply by the reciprocal, which is what? What's the reciprocal of 3? 1/3. Okay, so pi over 2 times 1/3 is what? Pi over 6. Okay, now because this is plus here, if it's plus, it'll be negative pi over 6. Okay, and then that means that the graph is moving left pi over 6 units. Okay, and then again we're going to do one complete period. Okay, so one period goes from B to B plus your period. So your B value is negative pi over 6, and this will be pi over 6, negative pi over 6, plus 2 pi over 3. So to add those together, I need what? Common denominator, which is what? 6. So negative pi over 6 plus, to get to 6, I multiply by 2. So negative pi over 6 plus 4 pi over 6 is what? 3 pi over 6. What does 3 pi over 6 reduce to? Pi over 2. Okay, so one period is negative pi over 6 to pi over 2. So this tells you where you're going to highlight. See how with this one, negative pi over 4 to 7 pi over 4? That's where we boxed it in. This is where we're going to box this one in.
So would you get it wrong in a quiz if, like, you boxed a period, but it wasn't that exact one?
No, I wouldn't.
You wouldn't mark it wrong. It just has to be some period on it.
It just has to be one exact period. But I would like it
You would like it, but you won't mark it wrong.
as long as it's one
Okay,
period.
as long as it's one.
Yes.
Okay.
All right, and then for this one, what do we want our scale to go by? Yep, so we want the scale to go by pi over 6. Okay, so then this is 1 pi over 6, 2 pi over 6, 3 pi over 6. What's 3 pi over 6? Pi over 2. 4 pi over 6, 5 pi over 6, 6 pi over 6, which I'm just going to write as pi. 7 pi over 6, 8 pi over 6, which would be 4 pi over 3. Okay, and then like I said, you can just do every other one, that's fine. This would be negative pi over 6, this should be negative pi over 2. Now, if you get stuck on the pattern, you can always plug in these values to see what they're going to be. Okay, and if you got something that wasn't a whole number, you would just go to the next one. Okay, but hopefully we are getting better at knowing our patterns. So again, you want to start at your phase shift. So if your phase shift is negative pi over 6, then that's probably where I'm going to start. Because if I plug in negative pi over 6, I get negative 3 pi over 6 or negative pi over 2. So when I add that to pi over 2, what do I get? 0. So if you plug in your phase shift, what should you always get inside here? 0. So the cosine of 0 is 1. And then this is 1 plus 1, which would be 2. Okay, so at negative pi over 6, I'm at 2. So because that's my max, I'm just going to label that. Okay, so then following my pattern, if it's negative pi over 6 to pi over 2, I know at pi over 2, that's the next place where I'm going to hit my maximum, because this is cosine. Okay, now you can either reason this out. Normally, where's your minimum for cosine? Negative 1. But then we shifted it up 1. So now your new minimum is 0. And that's going to happen halfway in between. So how many units is 1 period on this? Okay, so if it's 1, 2, 3, 4 units, I know the minimum happens halfway in between, which would be at pi over 6. And if I wanted, I could also just plug in pi over 6 here. And if I did that, I'd have pi over 2 plus pi over 2, which is pi. Cosine at pi is going to be negative 1. Negative 1 plus 1 is how you get 0. Right? So then, like I told you before, halfway in between those, on the original graph, it hits the x-axis, but we have a shift, which means that we have to find the middle point. So what's the middle point between 2 and 0? 1, right? 2 plus 0 is 2. 2 divided by 2 is 1. So if this is 2 units, this will be 1 unit, and this will be 1 unit. And then can you guys see how this is the shape of your cosine graph? If you wanted to box that in now, you could do that. Okay, and then we're going to keep going with our pattern. So then, well, really, if it's 4, you could always count 1, 2, 3, 4. And that one's too big. This one's actually pretty nice because you have one on every single unit. Alright, and then here, and then here. This doesn't look as pretty as it should. I'm sorry. Alright, and then let's do the last one. Right, so we have to find the phase shift. So again, we can just take whatever we have and multiply that by the reciprocal of k. So your k value is 3. What's the reciprocal of 3? 1/3. So pi times 1/3 is going to be pi over 3. Is this going to be positive or negative? Negative. Why? Yep, if you have plus here, then you're going to have negative here. Now be careful because this could be a negative value. So if you take out the negative, that turns into a minus, which means this would be positive. Okay, so just keep that in mind as you do these. 8, so your k value was 3, which is how we got this. So this means I'm going to be moving pi over 3 units to the left. And then let's find our period. So it's your b value, and then b plus your period. So my b value is negative pi over 3. And then we're going to do negative pi over 3 plus our period, which this one's really nice. Why? You already have a common denominator. So negative pi over 3 plus 2 pi over 3 is just pi over 3. Okay, so you can go by pi over 3 um, on your scale. If you guys wanted to spread it out to every other one, you could do that too. I'm just going to label everyone as pi over 3. So 1 pi over 3, 2 pi over 3, 3 pi over 3, which is pi, 4 pi over 3, 5 pi over 3, 6 pi over 3, which is 2 pi, 7 pi over 3, 8 pi over 3, negative pi over 3, and negative pi. Right, so again, the first thing that we want to find is what is the point at which x value? What are we plugging in for x? Negative pi over 3. So you're always starting with your b. So if I plug in negative pi over 3, 3 times negative pi over 3 is negative pi. Negative pi plus pi is 0. What's going to be the sign at 0? 0. So at negative pi over 3, I am at 0. Oh, I did that last time. Okay, so this is negative pi over 3, 0. What's your period? Okay, so at pi over 3, I should have 0, right? So I plot this point first. I plot this point second. And then because this is the sign is different than the cosine. What happens in between the two zeros of the sign? It's going to hit that same place again, right? Okay, so this is the max. This is the min. This is halfway between the max and the min. So the max plus the min divided by 2. Okay? All right. So to find my maximum, what's usually the maximum of sine? 1. Am I multiplying by anything or shifting it up or down? Nope. So the maximum is still 1. Now that happens halfway in between here. So I'm just going to go ahead and estimate. And because I don't want this to be super small, I'm actually going to change my y scale. So if I change my y scale, I just have to write it. So y scale in this case is by halves. So halfway in between, I'm going to be at 1. Halfway in between here, I'm going to be at negative 1. Bless you. Okay, so see how that's going to be your 1 period? From negative pi over 3 to pi over 3. Okay, and then we're just going to continue. So for this one, notice how points are on every single one. So I have a point here, point, 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 point. Yes, that's the middle one. Yeah.
Oh, yeah.
And then, so halfway in between here, I go up. Halfway, I go down. Halfway, I go up. Halfway, I go down. Up. Down. Halfway, I go up. Halfway, I go down. Okay, and then I'm going to curve this through. Well, just start your own YouTube channel. Okay, so then here's your graph. Isn't it beautiful? So remember that the 3, what does the 3 do?
Compresses it.
Hold up, it's a horizontal compression. you see the higher frequency. Okay, so one thing that your sine and your cosine graphs can model is blood pressure and heartbeats. So that's what we're going to talk about next. So each time your heart beats, your blood pressure is first going to increase and then decrease. It decreases as the heart rests in between your beats. The maximum and minimum blood pressures are called the systolic and diastolic pressures. Your blood pressure reading is written as a systolic diastolic. So a reading of 120 over 80 is considered normal. A certain person's blood pressure can be modeled by this function. So you have P of T equals 115 plus 25 sine of 160 pi T. And it says P of T is the pressure in mmHg, okay, which means millimeters of mercury. Okay, and then the time T is going to be measured in minutes. Okay, so I want us to understand the output and the input. So the output is your P of T, and that's going to be the pressure in mmHg. So when you have to do this on your test, you will have to do your units, which is why we're writing this out so we can remember that. And then the time is going to be represented by T, and this is going to be the time in minutes. So for part A, it says to find the period of P. So we know that the period is found by using 2 pi over K. Well, the K value is always in front of our, what we said, X. It's our input value. This time our input value is T. So the 160 pi, that's going to be your K value. So if I want to find the period, I'm going to do 2 pi over 160 pi, which is just going to reduce to 1 over 80. Right? Now remember that the period relates to the x-axis. Or your input value. So our input value is T. So therefore, this is your symbol for therefore, 100 over 80 relates to the time in minutes. Okay, so this represents 1/80th of a minute. Okay, so if the period is 1 over 80, that means 1 over 80th of 1 minute. So for B, it says find the number of heartbeats per minute. Since there is one heartbeat, in 1/80th of a minute, in 1 minute, how many heartbeats are there? 80. In 1 minute, there are 80 heartbeats. Okay, so your period is going to relate to your x-axis, your input. So in this case, it represents the time. So it would be 1/80th of a minute. So if there's one heartbeat and 1/80th of a minute, that means that there are going to be 80 heartbeats in 1 minute. Okay, and then I'm going to show you your homework, which is on